So I'm going to skip that second example because I'll do it before we start the worksheet in class. That way everybody sort of has one more final chance to ask me questions and make sure that they get it before we have to make our own on the worksheet. Instead, I'm going to jump us to the next two examples, which are more about interpreting that box plot, because that's another question I like for exams. And it's sort of important in general to be able to interpret these things if we see them in a paper for whatever our discipline is. So the first example we have is a box plot with case prices still from different vineyards along the Finger Lakes. What? I keep doing these things. So we've got our different vineyards, and I got some questions that come next. So the first question says, what lake region produces the most expensive wine? So I want you to take a moment, if you can, just pause and put your answers to each of these, and then I'll just quickly run through them. So most expensive, you should have chosen Seneca, right? We're just looking for the largest max here. That's all we want. And then produces the cheapest wine, we're looking for the lowest value. So that's also Seneca. So we've got max and min in the same place, Seneca. All right. Now, if I want to buy a case of wine for someone and I want them to know I spent money, Seneca's not a great place to go because they don't know where I am in this. Even if I bought this most expensive case price, unless they get on Google, they're not going to know that I just put out a lot of money. So a question I might care about is, which region are the wines generally more expensive? So this one, what I would be looking at is the box portion of the box plot, right? This is the middle 50%. These are the typical values. And so the box portion of the box plot is the highest in Kyoka. I don't actually know that I'm pronouncing any of these things properly. It's fine. And then the last two questions, we're talking now about spread instead of about extreme values or center. Largest spread using the range. Well, we're back to Seneca, right? Max and min are the highest for both there. So we're in Seneca. And then the largest spread using IQR. Visually, IQR is just talking about the box section of a box plot. And we can see that Cayuga has the largest or longest box and therefore the largest IQR. So our second, I hate this. Our second example, I'm going to give you again a moment here. Pause the video, try this out. This one is even more similar to something you would see on an exam. Okay, so if you paused it, let's just go through this multiple choice question here and just treat it like it was a true-false question. And we can kind of see why each of these is either right or not right. So 25% of females have weights more than 128. So we're looking at females. More than 128, so 128 is right about here. More than would be, yeah, that's exactly what a box plot does. Our questions about box plots are either going to be making sure that we know the 5-number summary or making sure that we realize the 5-number summary divides our data up into 25%, right? Into even amounts like we saw when we first talked about 5-number summary. So this is true, which we're not looking for. We're looking for not correct. B, the median weight of male students, okay, so now we're talking about males in a median. We know that's the middle of the box plot, is about 162. Yep, that looks right. Okay, the mean weight for female students is about 120 because of symmetry. All right, so we're talking about females, we're talking about mean, and we know that we can't see a mean on a box plot, right? So we're kind of sitting there going, what the heck? But then they mention this, because of symmetry. So can we tell that our female data is symmetric? Yeah, we can. Look at this thing. It looks beautiful. It's about the exact same amount to either side of that median. And remember what we had before. The whale is when we pull our mean over, but if it was symmetric, we had the mean and the median right in the same place. So it turns out, since my median is about 120 and it's symmetric, this is also true. But if I wasn't sure, I would just keep going on until I could find something that was obviously glaringly wrong. So let's keep going. D, the males have less variability than the females. All right, variability. Remember, that's just another way to talk about spread. Spread is how far, look at the male data. Whether we're doing range or IQR, the male data is much more spread out. Less is not the right word here. That is definitely our incorrect statement. So even if I wasn't sure what the heck C was saying, I should have been able to get D. And then the last question, about 50% of males have weights between 150 and 185. 150, 185. Yep, all of that is 25 plus 25, 50%. All right, and then part B, 25% of the males in the class weigh at least what amount? This is a question a lot of students make mistakes on. All right. The most common mistake is to tell me the answer here is 150. The issue is that it says at least. At least is the right-hand side. It is a greater than or equal to. So the correct answer here is that 185-ish, because at least 185 is 185 and more. That's what you're looking for. So be careful about directional keywords on questions like B. At least, more than, means you want the 25% or the 75% or the 50% to be on the right, versus a less than or an at most would be on the left.